Okay, welcome to today's session. Today we are going to discuss about radicals. What is radical expression? Okay, see, what is radicals? Radicals we can define like this. See, this is the square root sign. This symbol is called as radicals, radical sign. So there is a value inside the symbol. It's a, and there should be an index here, n. So we are going to take the root of a number, root value of a number. So what type of root determines the number of, what type of root determines the value of this n. So this is a radical. Normally, what is the basic idea behind this? Let's see the 2 square. What is 2 square? 2 square is equal to 2 times 2. The value is 4, right? So we know that 2 to the power 2 is written as 2 times 2. The value is 4. So this is an exponent. So this exponent is the value of this exponent equation. So going forward to 2 square to the value 4, the radical means we are going backwards. And we know this value and we know the power, and we need to find the value of the base. So here what we are going to do is let's see, find the square root of the value 4. Square root, we can write here the value is 2. So this means what number makes a power of 2 gives the value 4. So the base value we don't know. So we need to find the base value of this. That's why we call going backwards. So we can say that 2 times 2 is 4. So what's square root? So the base value is 2. So the square root of 4 is 2. And square root is 2. And the other words, what's the 2 to the power 2 is 4. So this is a forward direction and this is a backward direction. This is it, very simple. So when you want to find the exponent value 2 square, this is 4. So when we have the value 4 and you need to know the what base raise the power 2 gives the value 4. So this is the 2. This is we take square root. So both are interconnected. So the exponents and radicals are related. We're going to the next part. Let's see the parts of a radical expression. See, this is the what is a radical expression, Max? Let's go for the definition. A radical is a symbol used to represent the root of a number. Root. If you want to find the root value of a number, we use the symbol radical. The most common radical is square root. Yeah, it's true. Most commonly we are using square root. So very rarely we are taking a cube root or fourth root or fifth root. It's very rarely. Most commonly we are using square root. So this is the basic symbol of a radical expression. So this is a and this index n. So what is this symbol is radical symbol. Okay, you got it. Then n is an index. This is n. What is n? N is called the index of the expression. This determines which type of root we are going to take. If n is 2, it's square root. If n is 3, it's cube root. If n is 4, it's fourth root. So but what's a? There's a value inside the square root symbol. That's a. This we call as radicand. Radicand means the value we are going to take the root. So if there is no index, we probably see that there is no index. So this one we can assume as square root. Why? Because if there is no n value here, defaultly we need to assume that it's a square root function. Okay, let's go to the next topic. So this is the some some examples. See, expression root 25. We know that this is square root because there is no n value here. So this is a square root. What's square root of 25? What value time makes the power 2 gives the value 25. This is 5. 5 to the power is equal to 5 times 5 is equal to 25. The value is 5. Answer is 5. So root of 49, the same thing. That's it. 7 square. 7 times 7 is equal to 49. The value, the square root of 49 is 7. So let's see the cube root. This is cube root. See, there is n value mentioned here. That's a 3. So this third root, that means cube root we call. What's cube root of 8? We know that 2 times 2, 4 times 2, 8. What is it? This is 8. So what value multiplied 3 times it by itself got the value 8? It's 2. So the cube root of 8 is 2. So fourth root, see this here, this number n is 4. So fourth root of 16. Same thing, we can, what value itself multiply 4 times to get the value of 16 is again 2. See, 2 times 2, 4 times 2, 8 times 2, 16. So the fourth root of 16 is 2. That's it, very simple. So moving forward, radical see what we call is radical exponent, radical expressions and exponents are related. How it is related? We can see that, for example, we go for a to the root n. This is a basic expression of a radical expression. So this is, we can return in the form of exponent form. How? We can directly put a to the power 1 by n. We have n in the index. We can just put the reciprocal of the index value here. This is how they relate. Any time in the calculation, we can convert radical expression into exponent expression, or exponent expression into radical expression. If you want to convert back to this into the radical expression, we can put this. Say, depends upon the requirement of our problem. Okay, this is how they relate. Then see what he does. No, all the radical expressions doesn't have a whole number. Before you see square root of 4, cube root of 8, fourth root of 16, this all comes in a whole number. So but keep in mind, every radical expression, every root value or every square root value of a number is not a whole number. There should be a rational numbers also. See, if we go for take a square root of 2, it's not a whole number. It's will become a decimal number. Square root of 5, it's a decimal number. So every value doesn't have a perfect root. Okay, this is called, we call as irrational number. Rational numbers means it's a not a perfect number. It's a decimal will continue like this. So normally what we are going to do is, we are not converting this kind of square root back in terms to convert into decimal point. If we encounter if we got a solution of root 2, this doesn't require to convert into a decimal point, because we can put as it is. This is the solution. So some problems you will see the final answer is root 2. So that problem, that stage, no need to convert this root 2 into decimal point. We can just write root 2. We can underline and we can finish the solution. Okay, answer. Until and unless if the question required to do that. If the problem required to do convert this into decimal point, or to convert this into a decimal value, we need exact value, then only we need to convert. Otherwise you can put this as it is. Okay, let's move forward. We can see the radical rules. So the first two rules are product rule and quotient rule. So the product rule is very easy, as the same as the exponent rule. We can say a dot b is equal to root of a dot b. In this reverse order also, we can see a dot b. We can split it into root a dot root b. This is it, the product rule. Very easy. And if we go for example is 9 times 16, the inside the square root, we can just convert into root 9 dot root 16. You know the answer of the root 9 dot root, this is 3 times 4. Answer is 12. It's very easy. If even if you're not applying this one inside the if you didn't apply the product rule, we can just see the final answer is 12. Okay. Okay, then we go for the quotient rule. Quotient rule is same thing, a divided by b. Inside the square root symbol, we can convert it into root of a divided by square root of b, until and unless b should not be equal to 0. If b is equal to 0, what happened? There is no solution for the expression. The denominator will be 0. So this is a quotient rule and a product rule. Keep in mind, we can convert, we can open the square root and split it into 2 if you have a product term inside, expression inside the square root. Same thing, if a fraction inside the square root, we can split it into like this, 2 terms, numerator and denominator. So just moving forward, this is a quotient rule. This power of radical. So here we're going to see is power of a radical and radical of a power. Both are same, but I will give you the examples. Power of a radical. So first we need to write a radical symbol, a to the power n. So a to the index n. We are raising a power n. What here is going to do is, we'll see, we can convert this into exponent form. So what is this? As per the exponent rule, a to the power 1 by n. Convert this into exponent, and again it's raising a power n. What is exponent rule says? If a value raise a power, or if a value raise a power, again we raise a power, the value can be written as a to the 1 by n dot n. So the value will be a to the n by n. N by n is 1. So the value is a. Same thing. This is how the power of a radical will work. If there is same n and this n is same, then you can simply write it will cancel each other. The answer will be a. If the both are different, square root of n is here and the raised power is m. So what happened? A to the power 1 by n, the whole power m. The value will be a to the 1 by n dot m is equal to a to the m by n. We can just simply make this this radical expression into an exponent form. Okay, then radical of power, the same thing. See, a to the power m. If you raise a same thing, index is m. Same thing happen here also. So what happened is a to the power m, convert this into exponent form, 1 by m. Same. So a to the power m dot 1 by m is equal to, this m and m will cancel. So a. If that is different, if this is different, let's simplify a radical expression. Root of 60 x square y s to power 6 s to minus 11. This is the radical expression. Simplify it. So how we are going to simplify it? First we need to analyze what's the first rule. Maximum pull out perfect squares out. That's our first strategy. So before we are going to do is, we need to find the perfect square. So there's a variable x, y, z here, and here is a number 60. So 60 we need to factor out. So let's factorize 60 here. By how we factorize 60, we write here by 2, divided by 2 is 30. Again 30 divided by 2 is 50. Again how we can divide by is 5. It is 3. Finish. 3 we cannot factors again. So we can rewrite this expression as it is. See, root of 2 times 2, 2 times 2 times 5 times 3. We can write x square, and y square can be split it into 3 parts. So y square dot y square dot y square. Why I am doing this, right? I want to just make the perfect squares out. So as per the product rule, this y square plus y square dot y square is 2 plus 2 plus 2, 6 y raised to 6 is same as per the product rule of exponent. Then there's a z raised to minus 1. It's a negative exponent, means it will go down to the denominator side. Okay, denominator side. So z raised to we can split it into z square, z square, z square, z square. So 5, 2, 4, 6, 8. Sorry, then it should be 10. 2, 4, 6, 8, 10. Then 1 left is z raised to 1. So this is how we can write this radical symbol like this. So from here, what we need to factor the perfect squares, pull out the perfect squares. So 2 times 2 is 2 square, it's a perfect square. So we pull out this also 2 times 2 is, we can return as 2 square. So we can pull out first 2 from the radical symbol 2. The next is x we can pull out because it's a square. Then y square, y square, y square. So 3 times y we can pull out because it's a perfect squares, because it's square root symbol. Okay, then from the denominator side, what we can pull out? Yeah, squares are 1 2 3 4 5, 1 2 3 4 5, 5 z's are there. We need to pull out 5 z, 1 2 3 4 5 z. Then what left inside the square root symbol in the numerator side? It's 5 times 3. 5 times 3 is left, because if you cannot pull out this one, it's not a perfect square. What's left in the denominator side? It's z raised to 1. Okay, so moving forward to the more simplified form, it is 2x 3 times y is y cube, y cube. Then what left there is 3 times root 15 left here. Then denominator side, how many z? Is raised to 5. Is raised to 5 left there. What's left? Root is left here. So this is the simplified form of. More simplified, normally there's a number here and there's a radical symbol here, so we need to put it together. That's the most commonly used way to make the simplified term. So root 2 root 15 x y cube divided by z raised to 5 root of z. So this is the simplified form of that radical expression. Okay, this is how we simplify the radical expression. So just see where we started and where we ended. So this is the radical expressions here. See, look at the expressions here. Wow, how complicated this is. Inside the root there is numbers, there's power variables are with different powers. So then this one we convert this into this form. See how simple it is. For the further calculation or further problem solving, this kind of simplified form is very useful. Always keep in mind, when we have a expression, break it into pieces or simplified or perfect, pull out the perfect squares out, make this in a simplified form. Then only we can analyze this and we can think for what to do next. If we need to do that, we need a perfect, or we can need a simplified form. Okay.